MCA Countdown number 2. This one, how many solutions does the following system of equations have? Okay, so all they're looking for is not necessarily just the answer. They want to know if it has one solution, no solution, infinite, or two solutions. Well, first of all, this isn't going to be an option. So if we look at this, we can just try to eliminate the y's. If we do that, we have 3x plus 10x equals 13x equals 13. Divide them by 13, and we have x equals 1. So if we can get basically the variables, we have a variable in there, which means your answer is going to be A. No solution would have been if like both variables dropped out and it was unbalanced. Infinite would have been if both variables dropped out and it was still balanced. All right, next one. Graph a scatter plot using the given data. So 1, 2, 20 is right here. 2, 230 is right there. 3, 260 is right here. Excuse me. 4, 260 is right here. And then 5, 280 is right here. So when they want us to graph a scatter plot using this data, what we need to be doing then is making a line as best as we can. So a line is still going to be a straight line. So something along lines of like this. And it's just a quick sketch. Now, checking over here, does this show any correlation? Yes, it's positive. It's definitely going up. Draw a trend line. We just did that and predict the number of words per minute after 8 weeks. So looking through there, if I go up to 8, around here, I would say it'd be in the range of about 350 words per minute after 8 weeks. Next one, given these equations, determine if what we can tell about the graphs. They're asking about parallel, perpendicular, coincide, or neither. We're just checking the slopes. Negative 2/3 and negative 3/2. We can see they changed signs and they flipped, which means it's perpendicular. If we look over here, we both have the same slope of 2. So in that case, it's going to be parallel. But we do double check for the other piece, and we see that these have different y-intercepts. So that means that they are going to be for sure parallel. Now, the reason we have to look at this is that if they were the same y-intercepts, that's what this word coincident means. That means that they would be the exact same, coinciding, they would be the exact same graph. So they would have an infinite number of solutions. All right, next one, write this in scientific notation. So I'll move this back 1, 2, 3, 4 places. So it's 3.4 times 10 to the negative fourth because I made it a small number. Check it again. 1, 2, 3, 4. Yep. Okay, next one over here. If I do 6.4 divided by 1.6, 64 divided by 16 would just be 4. So that's 4. And then now I can subtract these. So it's 4 times 10 to the 7 minus 2 is 5. Next one is the quadrilateral formed by the coordinates. Plug in those numbers. Is it a parallelogram? So let's see what that comes up with here. Negative 2, 5 is at...
Sorry.
Oh, that's fine.
Everything shut.
Okay, good. Perfect. Okay. Sounds good. All right, thank you. Try to hit positive. I'm not sure it worked. Negative 2, 5. Negative 2, 1, 2, 3, 4, 5. Oh, I'm going to go back here. Negative 2, 5 is going to be right here. And then 3, 1. 1, 2, 3, 1 is right there. Negative 1, negative 2 is right here. And 1, 2, 3, 4, 5, 6. 1, 2 is right here. Now, does this form a parallelogram? If we draw it, it appears to do that. 2, 1, 2, 3. This is actually off. It should be right there instead. If we draw that out, now technically a parallelogram would have both opposite sides be parallel. Let's just check the slope here. So up 1, 2, 3 over 1, 2, 3, 4. So up, so it's positive 3/4. This one's up 1, 2, 3 over 1, 2, 3, 4. Yep, these are both a slope of 3/4. Now check these two lines. This is going down 1, 2, 3, 4 over 1, 2, 3, 4, 5. So negative 4/5. This is going down 1, 2, 3, 4 right, 1, 2, 3, 4, 5. Also negative 4/5. So yes, this is a parallelogram. And the last one, plug in these four numbers, 1, 2, 3, 4, negative 1, negative 1, 2, 3, 1, 2, 3, and then 2, negative 1. So 1, 2, negative 1. So they're saying this would form a parallelogram, so I'm looking like it's going to be looking like this. So I want my other point to be somewhere down here. See, I went down 1, 2 over 1. So I go down 1, 2 over 1. There's my fourth point. I drew it. So this point right here would be 1, 2, 3, down 1, 2, 3. So that fourth point would be at 3, negative 3. Oh, I'm sorry. 3, negative. Yep, 3, negative 3. And that is all for this one.